In this problem, let's do a multiple comparison of means. Refer to the completely randomized design of example 10.4, in which we conclude that at least 2 of the 4 brands of golf balls are associated with different means distance traveled when struck with the driver. We use remain a robot. First, use tricky multiple comparison procedure to rank the treatment means with an overall confidence level of 95%. Second, estimate the mean distance traveled for balls manufactured by the brand with the highest rank. In mean, we are going to use a 95% confidence level to construct the confidence interval for all difference that we obtained in the previous problem, that at least 2 of this brand or 1 brand differ from the other. But let's compare. In order to compare all of this mean, we are going to construct the confidence interval of all difference, all pair difference. Then after that, we are going to reach our conclusion. First of all, we need to do several comparisons because we have 4 means, 4 population. To obtain the number of comparisons that we have to do, remember, from 4 means, we need to compare 2 by 2 pair. Then we need to count the number of possible combination of 2 among 4 means is given by this number. 4 combination 2 is 4 factorial divided by 4 minus 2 factorial, 2 factorial. Then in this case, this is equivalent to 4 times 3 times 2 factorial, or 2. And in the denominator, we have 2 factorial times 2 factorial, which is 2. We can cancel this with this. Actually, this is equal 4 times 3 divided by 2. That is equal 6 possible comparison. We can use also the formula that is given in the book, that if we have 4 means, the number of comparison, pair comparison that we can do between these 4 means is given by 4 times 3 divided by 2. That is the general formula to obtain the number of comparison that we can obtain from n mean. That is the first step. Then after that, we need to go to StatCrunch. I strongly recommend from now on, do all exercises first in StatCrunch, and after that, show your work in a way that you must obtain those answers using formulas and explain the procedure step by step. How can we do that? Let's go to StatCrunch. This is a problem. We can send directly this problem to StatCrunch or to Excel, but when we have this data in StatCrunch, let's go to Stat. In Stat, let's go to ANOVA. And in ANOVA, because we have only one factor in this problem, which is the brand, select one way. We select the column where is located my data, and we select 4 column in which are located my data according to the brands. And let's select here compute Tukey HSD at 95% level confidence. We are going to construct confidence interval for all of these, the difference between all of these mean. We have now studied the Levene test to test the hypothesis that 2 populations have the same standard deviation. We used box+ in the previous problem to test this condition, very important for this ANOVA procedure. Let's select this test now and let's compute that. That is the result. We have the ANOVA table in this section. We have all mean here, the ANOVA table. We have the Levene test. Can you see this Levene test? The Levene test, that is the reason I request that you obtain this answer using table. You can use in the midterm technology to obtain the answer. You have no idea how can you test that all standard deviation of all of this population is the same. But using this result, this p-value in this result, you can assume that all of these standard deviation are equal, because the p-value is so big. The assumption in this test is all standard deviation are equal. This is the assumption. According to this assumption, you select a sample, we select it, and we compare all standard deviation, and our p-value in this case is so big. If the p-value is so big, we cannot reject the assumption that the variance or standard deviation are equal. If we cannot reject it, let's assume that they are equal. Here we have all two-key comparison or pairwise. And let's go again to we have all of this result here. Which one is your work? You have all of this from technology. Which is your work? First of all, let's construct a table with all of this comparison. That is the table you have to construct. In this table, we compare brand A with B, C, and D, but we subtract the mean of brand A from the mean brand C, and D. Then the first comparison is brand B and A, but A must be subtracted from B. And also you can observe here that we have 1, 2, 3, 4, 5, 6 comparison. The comparison that we need when we have 4 means. Then the first comparison, B and A, but A must be subtracted from B, is the mean of the population B minus the mean of the population A, is given by this confidence interval. In this confidence interval, you can observe that the difference between these two means is at least 4.7, but no bigger than 15. That is the interpretation of this confidence interval. And let's copy here in this table the other difference means, the confidence interval for the difference between mean A and C, but remember A is subtracted from C. The confidence interval is at least 13.6, but no bigger than 24.7. Between D and A, the same thing. Then let's analyze what happened in the first case between A and B. Remember, when you have two values, A and B, if you do this difference between B and A, between these two numbers, this result could be positive, could be 0, or could be negative. Three possibilities. When this result is positive, for example, 5, it means that B is 5 units bigger. B is 5 units bigger because it's positive. But if I said that is negative 5, then I will say that A is 5 units bigger than B. Then the sign of my result indicate which one of these two is bigger. If the sign is negative, the bigger one is A. If the sign is positive, the bigger one is B. And if the difference is equal 0, then we can conclude that B is equal to A. Then taking this in consideration, let's interpret all of these confidence interval. The first confidence interval, B and A. When we compare B and A, we observe that the difference between B and A is at least 4 and no greater than 15 is all possibility are positive, then B should be bigger than A. In the second interval, the difference also are positive. We conclude that C is the first one is bigger than the second one. C is greater than A. Let's go to the third interval. In this third interval, the difference could be negative, could be 0, or could be positive. In those cases, it's possible that D and A are equal, but because in this interval we have more negative number than positive numbers, because it's from negative 7 until positive 4, we have more negative number. That implies that the second one could be bigger than the first one. And also, we need to take in consideration that these two means could be equal. Then we interpret this in this way. The mean of the population A is bigger than the population D or equal. Then let's interpret the next interval. This next interval is positive, all positive. Then that implies that the first mean is bigger than the second mean. C is bigger than D. The next interval, all values are negative. This implies that the second mean is bigger than the first mean. B is bigger than D. And the last one, the same result. Because all possibilities are negative, this implies that the second mean is bigger than the first mean. And using this table, then let's order all of these mean from the biggest one to the smallest one. What is the biggest one? Is 269. After that, 261. After that, 250, and the last one is 249. Then the first one is C, the second one is B, A, and D. Then let's compare the first two, C and B. What was the conclusion that we obtained from C and B? C was bigger than B. Then we need to write that. B and A, we conclude here that B is greater than A. Then we can write this. And A and D, in this, we conclude that the mean of A is bigger than or equal to the mean of D. Because of that, we need to draw a line above A and D to indicate that A and D could be equal, that there is no significant difference between A and D. As you can observe, A is 250 and D is 249. There is no significant difference. However, between C and B, there is a significant difference, and between C and A and D, there is a significant difference. Also, between B and A, there is a significant difference, and between B and D also. However, between A and D, there is no significant difference. And we can conclude that C is the biggest mean. The branch C ball reached the highest distance. And we are 95% confident that all these intervals contain the true difference between the means. That is our conclusion in this exercise. And we can write this conclusion in this way, or we can write it in this other way, or order it from the smaller to the biggest, or the biggest to the smallest. And this is our conclusion for this exercise. That is your work. Your work is this table, and this table. That is your work. And this is the conclusion. You can read it from the PowerPoints.